Alright, this is your chapter 9. Sorry, let me focus that. Okay, your chapter 9, I know it says quiz review, but this is going to end up being a test grade, so that we can call this our chapter 9 test review. So consider the picture below to identify the given angles as supplementary. So remember, supplementary adds to 180 degrees and it makes a straight line. Okay, so supplementary, complementary is 90 degrees, which makes a 90-degree angle. Adjacent, if that would be neighbors. Okay, they're neighbors, they live next door to each other. Vertical is across from, or none. Okay, so we have angle BOC. So if I were to outline this, I go B to O to C. So there's the angle I'm talking about right here. Okay, and angle COD. So C to O to D. So when I put those two angles together, I need to ask myself, does it make a straight line? No, those don't make a straight line. So it's not supplementary. Does it make a complementary or 90-degree angle? Nope, it doesn't make a 90-degree angle. There would be a little right angle there like there is right here. Okay, the square that tells us it's right angle, plus this is not 90 degrees. It doesn't make a perfect corner. So it's not supplementary or complementary. So now we have to pick from adjacent or vertical. So vertical would be across from each other. That means we also know vertical angles are the same size, and those obviously are not the same size. But vertical angles are across from one another. So say this is my backyard, and this is Miss Dedion's backyard. Miss Dedion's backyard is not across the street from mine. We're neighbors. So if we acted like this was a fence right here, I could peek over my backyard and over the fence into her backyard because we're neighbors. So this is like a fence. We share a fence. We're neighbors, and when we're neighbors, we're adjacent. So those two angles are only adjacent. The next one we're going to look at is angle AOF. So AOF. And FOE. So FOE. When we put those two angles together, we have to ask ourselves, does it make a straight line? No, it does not. Does it make a complementary angle, a 90-degree angle? Well, they sure do. When I put them together, they make up this entire 90-degree angle. So these would be complementary. And then we have to determine if they're neighbors or if they live across the street from one another. Well, just like these two over here, if this is my backyard and this is Miss Dedion's, we can peek over this fence right here into each other's backyards because we're neighbors. So we share a fence. So we are also adjacent. Okay, angle COB, so COB, and angle DOE, so DOE. Well, when I put these two angles together, there is no way for me to be 100% positive that they make a straight line or a 90-degree angle. So I can't pick one of those. Are they neighbors? Well, no, they're not neighbors, because if this was Miss Dedion's backyard, and this is my backyard, and this is your backyard, you and Miss Dedion are not neighbors. I'm stuck in between you two. So we're not adjacent. They're not vertical, because, well, vertical angles are directly across from each other, and they're identical, and those are obviously not the same size. So these would be none. And last but not least, we have angle BOC. So this angle again, angle BOC, and angle BOF. BOF. Okay, so we have to ask ourselves, when I put these two angles together, do they make a straight line? Well, here and here, those do make a straight line this way, so they are supplementary. Remember, supplementary and straight line both start with an S. Complementary and corner both start with a C. Okay, now we have to ask ourselves, are we adjacent or vertical? Well, if this is my backyard and that's Miss Dedion's backyard, we share a fence right here, so we are neighbors. So they are also adjacent. Okay, number 5, draw a pair of vertical angles. Well, we know two lines that intersect each other, okay, will create vertical angles, and they're the angles that are opposite one another. So angle 1 and angle 2 right here would be vertical angles. This is what I mean by across the street. In my house, in the Steadion's house, we live across the street from one another. So we could say angle 1 and angle 2 are vertical angles. Remember, angles cannot be vertical and adjacent at the same time. You can't live across the street from one another and next door to one another at the same time. So you're either vertical or adjacent. Number 6, determine the value of W. Okay, well, if you remember from the steps that we talked about to solve for a variable, step 1 is find a total. And that's either going to be 180 or 90. Okay, it's going to be 180 or 90, so it's going to be one of those. Step 2 is subtract what you know. Step 3 is going to be set up the equation. And step 4 is going to be to solve the equation. So we're going to follow those steps because I'm solving for a variable. So, find a total. Well, this is a 90-degree angle, so my total is going to be 90. So I'm going to write that down. There's my total. I'm going to subtract what I know. Well, I know 56 degrees, so I'm going to subtract 56. Can't do 0 minus 6, so I'm going to borrow from the 9. 10 minus 6 is 4. 8 minus 5 is 3. Okay, so I subtracted what I know, and I have a remainder of 34. Now I'm going to set up the equation. Well, if I know the remaining angle degrees is 34, that means that this W plus 12 has to equal 34. So 34 equals W plus 12. So I set it up. Now I'm going to solve it. I'm going to cut it in half, circle my variable. To isolate this, I need to do the opposite of adding, which is subtracting. So I'm going to subtract 12 from both sides. 4 minus 2 is 2. 3 minus 1 is 2. So 22 equals W. Number 7, two lines intersect each other and form 4 angles as shown in the figure. Find the value of Y. Well, I know that these are vertical angles. They're across from each other. And one thing we know about vertical angles is that they are identical, or they are the same. So that means that this equals this. So 3y equals 126. They equal each other. So to solve this, I'm going to cut it in half. I'm going to circle my variable. Right now, y is being multiplied by 3, so the opposite of multiplying is dividing. So I'm going to divide both sides by 3. Top in, bottom out. 3 won't go into 1, but it goes into 12 4 times. 4 times 3 is 12. 12 minus 12 is 0. Bring down your 6. 3 goes into 6 2 times exactly. So y equals 42. Okay, number 8. Determine the value of x. So we are going to follow our steps again. So find a total. Well, this makes a straight line, so that's 180 degrees. So 180 is my total. Step 2 is subtract what you know. Well, I know 35, so I'm going to take out 35 or subtract it. I can't do 0 minus 5, so I'm going to borrow. 10 minus 5 is 5. 7 minus 3 is 4. And 1 minus 0 is 1. Now, step 3 is set up our equation. So this remaining angle over here has to be 145 degrees. So x minus 7 has to equal 145 degrees. Step 4 is solve. So I'm going to cut it in half, circle my variable. In order to isolate this, I need to make minus 7 go away. So the opposite of subtraction is addition. I'm going to add 7 to both sides. You get 152. So x is 152. Okay, next page. Number 9. Angle 1 and angle 2 are supplementary. Supplementary is a straight line which is 180 degrees. Okay, if the measure of angle 1 is 97 degrees, what's the measure of angle 2? Well, in order to figure this out, I'm going to take my total, 180, and I'm going to subtract 97. I have to borrow. 10 minus 7 is 3. Can't do 7 minus 9, so I'm going to borrow again. 17 minus 9 is 8. So the measure of angle 2 is 83 degrees. Number 10. Angle 1 and angle 2 are complementary. Well, complementary makes a corner, which I know is 90 degrees. So if the measure of angle 1 is 21.5 degrees, what's the measure of angle 2? So we're going to solve this the exact same way. I'm going to take my total of 90, and I need to subtract 21.5. But 21.5 has a decimal, and 90 does not. So I need to add a decimal to 90. Remember, decimals look like periods, and we know periods go at the end of a sentence. So I can add my decimal and my 0 to 90. Now I can line up my decimal points, and I can subtract. Can't do 0 minus 5, so I need to borrow, but I can't borrow from here, so I'm going all the way to 9. That becomes an 8. Now I have 10. I can borrow from the 10 now. That's a 9. 10 minus 5 is 5. 9 minus 1 is 8. And 8 minus 2 is 6. So the measure of angle 2 is 68.5 degrees. Number 11. In an obtuse scalene triangle, one angle is 24 degrees and another angle is 105 degrees. What is the measure in degrees of the third angle of a triangle? Well, I know that all the angles in a triangle have to add up to 180 degrees. So angle 1 plus angle 2 plus angle 3 has to equal 180 degrees. A way for you to remember that is there are 3 angles in a triangle and there are 3 numbers in 180. Okay, so what's the measure in degrees of the third angle? Well, if I know 2 of them, to figure out what's left, I need to subtract from the total. So 180 minus 24. Subtract the first one. Can't do 0 minus 4, so I'm going to borrow. 10 minus 4 is 6. 7 minus 2 is 5. And 1 minus 0 is 1. Now I'm going to take 105. So I've used both of these now. Away. 6 minus 5 is 1. 5 minus 0 is 5. So the remaining angle, or the measure of angle 3, is going to be 51 degrees. Remember to check this. You can add them all back together. 56 plus 105 plus 24, and you should get 180. Number 12. In an acute scalene triangle, one angle is 24.8 degrees, and another angle is 74.3 degrees. What is the measure in degrees of the third angle of the triangle? Well, same process as number 11 above. I'm going to start out with 180 because that's what all the angles in a triangle add up to. And I'm going to subtract what I know. So I'm going to take away the 24.8. But notice this has a decimal and 180 does not. Decimals look like periods, so I'm going to add 1 because periods go at the end of a sentence. And then my 0. And now I can line up my decimals and do my subtraction. Can't do 0 minus 8, so I'm going to borrow all the way from this 8. Makes that a 10. Now I can borrow and it's 9. 10 minus 8 is 2. Bring down your decimal. 9 minus 4 is 5. 7 minus 2 is 5. And 1 minus 0 is 1. So now I'm at 155.2. Now I'm going to subtract my next angle. That's 74.3. Make sure you line up those decimals. Can't do 2 minus 3, so I'm going to borrow. 12 minus 3 is 9. Bring down my decimal. 4 minus 4 is 0. Can't do 5 minus 7, so I'm going to borrow. 15 minus 7 is 8. So the measure of angle 3 is going to be 80.9 degrees. Remember to check it. You can add 80.9 plus 74.3 plus 24.8, and you should get 180. Numbers 13 through 16 say determine which of the following would form a triangle. Why or why not? Well, if you remember the triangle inequality theorem asks you to add the sides together, and they should always be greater than the third side. Well, if you also remember, I gave you a cheat for that to help you do this a little quicker. We are going to add the 2 smallest sides together, and they have to be bigger than the largest side in order for us to say, yes, this will form a triangle. So my 2 smallest sides here are 3 and 6. So I'm going to say 3 plus 6 has to be greater than 10. Well, 3 plus 6 is 9. Is 9 greater than 10? No. Okay. Number 14. My 2 smallest sides are 4 and 6. So 4 plus 6 has to be greater than the largest side, which is 8. 4 plus 6 is 10. Is 10 greater than 8? Yes, it is. So this will form a triangle. Number 15, my smallest sides are 8 and 11. So 8 plus 11 has to be greater than the largest side, which is 19. 8 plus 11 is 19. Is 19 greater than 19? No, it's not. So this will not form a triangle. Last one, my two smallest sides are 3 and 7. So 3 plus 7 has to be greater than the largest side, which is 9. 3 plus 7 is 10. And 10 is greater than 9. So this is true. This will form a triangle. Number 17 and 18 tell us to classify each triangle by its angles and by its sides. So we have to pick one of these, acute, right, or obtuse, and one of these. We're classifying it by both. Okay? So I'm going to pick one from the yellow and one from the orange. Well, remember, acute triangles are all cute little triangles. All the angles are less than 90 degrees. Right triangles have that right angle in them. Obtuse triangles have a big obtuse angle. Acute this way. Okay? So, if I'm looking here, I have to determine, are these acute, right, or obtuse? Well, the first thing I look for is a right angle, because that will immediately tell me it's a right triangle. I don't see one of those here, so I know it's not a right angle. Now, if I'm looking at this, these are all less than 90 degrees, so this must be acute. Now I have to pick from the orange side, equilateral, isosceles, or scalene. So if they're equilateral, they're all equal. Isosceles, okay, one way you can remember this is we have two eyes. Isosceles. There's two of those, so those are two sides. Scalene, the way I told you to remember that is snakes have scales. Ms. Clickman says no to snakes. I do not like them. Snakes have scales, so scalene is no sides. All right, so if I'm looking here, since this side has one tick mark, this side has one tick mark, and this side has one tick mark, that means they all have one, so that means they're all equal. So this would be an equilateral triangle. All right, number 18, same process. I need to pick from acute, right, or obtuse. I do not see a right angle in here, so I know it's not a right triangle. I do see a small acute angle here and a small acute angle here, which is awesome. But if I look at this angle over here, if I were to turn this into a 90-degree angle, this would have to go straight up. And it doesn't. That's an obtuse angle right there. It's a big obtuse angle. So this is an obtuse triangle. And then, unlike this one, where it showed us that all three sides were the same, this does not designate any sides being equal. So this has no sides that are equal, so this is a scalene triangle. Okay? Number 19 and 20, we're doing the same thing, so I'll kind of leave this right here so we can look at it. Okay, so remember acute, right, or obtuse. So the first thing I look for is that right angle, because that immediately tells me it's a right triangle, and I see one right here. There's a right angle here, so that's a right triangle. Then if I'm going to classify it by its sides, this side has one tick mark, this side has two, and this side has three, meaning that they're all different. Okay, they all have a different number of tick marks, so none of them are the same. So when none are the same, it's a scalene triangle. Number 20. Okay, let's see. Acute, right, or obtuse. Well, I don't see a right angle in there. There's no square. Obtuse is greater than 90 degrees, and none of those are greater than 90 degrees. Acute is all less than 90, which those are. So this is an acute triangle. Then I have to pick from equilateral, isosceles, or scalene. Well, I know it's not an equilateral because all the sides don't have a tick mark on them. My gut is to say that it's scalene because it doesn't say that any of the sides are the same by number of tick marks. But one thing that we learned about isosceles triangles is that when you have two equal angles, that means the opposite sides are also equal. So two equal angles, two equal sides means this is an isosceles triangle. Remember, you have two eyes, isosceles, two equal sides. Okay? Number 21 and 22, It says, write and solve equations to determine the values of x or y in each figure. So remember in isosceles triangles, sides equal sides and angles equal angles. I know it's an angle because it's got a little degree symbol there. So I'm looking for that degree symbol to tell me it's an angle. This is a side and it has to equal the other side. So 12 has to equal y plus 6. I'm going to cut it in half and circle my variable. In order to isolate this, I need to make plus 6 go away. So the opposite of adding is subtracting. Do that to both sides, and 12 minus 6 is 6. So y equals 6. On number 22, my angles equal each other, so I'm going to set up that equation. 3x equals 75. I'm going to cut it in half and circle my variable. Right now, x is being multiplied by 3. A number next to a letter means to multiply. Opposite of multiplying is dividing, so I'm going to divide both sides by 3. 75 divided by 3. 3 goes into 7 2 times. That would be 6. 7 minus 6 is 1. Bring down your 5. 3 goes into 15 5 times exactly. So x equals 25. That makes sense. 3/4 of 75 cents. Last but not least, problems 23 and 24 ask us to refer to this diagram. We're going to list one pair of vertical angles. Remember, vertical angles are across from one another. Okay, not next door. They live across the street. So angles 2 and 4, I'm going to list them all. Angles 2 and angle 4 are vertical angles. Okay, and then also angles 1 and angle 3. Angle 1 and angle 3. You don't have to list both of these. I'm just listing them all for you. You would only have to pick one. Number 24 says list one pair of adjacent angles. So I need angles that are neighbors. They share a fence line. So I'm going to go ahead and list all of them. You would only have to list one. So if I start here, angle 4 and angle 3 are neighbors. They share this fence line right here. Angle 4 is also neighbors with angle 1. So angle 4 and angle 1. Angle 1 we know is neighbors with angle 4, but angle 1 is also neighbors with angle 2. They are next door to each other, so angle 1 and angle 2. Angle 2 and angle 1 we know, but angle 2 and angle 3 are also neighbors. And angle 3. We already labeled angle 3 and angle 4 up here. So those are all the adjacent angles. Remember, they have to be next to each other. They're neighbors. They could peek over each other's fences in the backyard to look in the other person's backyard. So this is your review for your Chapter 9 test on geometry.